Now we're going to look at scientific notation. I kept referring to negative exponents, that we always have to, make everything positive exponents. Well, this is the exception that I referred to at least twice before. So, finding powers of 10. Our number system is based on tens, and we have easy ways of writing very large and very small numbers. So, find the following powers of 10. Now, 10 to the first, you should remember, is just 10. 10 squared, you need to write out 100. 10 to the third, well, 10 to the third, let me go use the cube, is 1,000. And 10 to the fourth, here I have to use the caret symbol. So a quick way to do this, if you noticed a pattern, if you write down 1 and then add the same number of zeros as the exponent. So there's my 1, add 4 zeros. There's my 1, add 3. The 100, you'd have 1, add 2, and here 1 and just 1 0. Now see if the pattern continues with the following products. 3.25 times 10 to the second. Well, if I can move the decimal 2 places, that would make it 100. So that's what I'm referring to here. Remember that 10 squared is equal to 100, and when you multiply with a number that ends in a lot of zeros, you can just add those zeros to the other number. But with a 10 raised up to a positive exponent, you can just move the decimal and add zeros. So look at the following. They're first written, this is called scientific notation. Okay, this is called standard. So here's a 0.9, 6.9 times 10 to the fourth. So I need 4 zeros, so this going around the 9s counts as 1, and then add 3 more zeros. This I only move the decimal 1 place. This one I need 7 positions, so I've got 2 places coming around the 32, but then if you'll notice I have to add 5 zeros. With a positive exponent, notice that the decimal place is moved to the right that number of places. If a positive exponent moves the decimal right, then what do you think a negative exponent will do? It'll move it in the negative direction. See what happens here. 4.9 times 10 to the negative 2. Look what happens. 3.25 times 10 to the negative 1. The decimal is understood to be behind the 5 right now, but moving it in the negative direction 1 space puts it here. What about this one? Well, I've got to move it in the negative direction 2 spaces, so I've come around the 6 and come around the 2, but I'm going to have to add a 0 to take care of the negative 3. So when it's in scientific notation, it's sort of nice in that when you see whatever the exponent is, sign and number, that's the direction and how many spaces you move your decimal. So multiplying with powers of 10 is a matter of moving the decimal either right or left depending on the sign of the exponent. A positive power, the decimal always moves right. Negative power, the decimal always moves left. Writing the numbers without the base 10 is called writing them in standard notation. So first one we're going to look at is when they're in scientific notation, going to write them to standard form, and then when they're in standard form, writing them into scientific notation. Now to write them in scientific notation, if you'll notice a pattern here, you have got to have one single non-zero digit in front of the decimal, and then everything else after, times 10 too, depending on which way the decimal moved. So why don't you try 1 through 4. Pause me just a second. So this one, I've got to move that decimal in the positive direction 3 spaces, so you should have 7100. This one, notice I have to move the decimal in the negative direction 3 spaces, so I'm going to have to add 2 zeros, so you should have 0.00105. Make your decimal big enough. You really don't need this 0. Usually it's put there so people will know there's a decimal, but I usually make a real big decimal so people will see it. So this one, did you end up with 0.000162? This one, 231 with 3 more zeros. because sometimes it does end up on your calculator in scientific notation. You won't see the 10. You'll see an E there. Let's see, 1.62. Let me see if I can get it. Whoops. That's what it would look like because it's understood to be base 10. Now, let me see, can I change this to a decimal? No, it won't let me. Pooh Bear. Well, let's try 0.000162 and see what it does. Ah, there it is. So the calculator up to a certain point with a bunch of zeros doesn't like it. So you can, I guess, check yourself this way. Put in your answer and see if it is the same thing. Now this, I don't think it'll change it. I think it just keeps it. So can we change it to scientific notation? I'm not right sure where that is. Nope, doesn't like that. I know what we can do. Let's put it as 2.31 to the 5th and see what it does. There it is. Okay. Oh well. Let me see. Now these problems, we need to write the following numbers in scientific notation. So pause me and see if you can get these. Let's see this one. The decimal is coming from the positive side. Okay, so this should be 3.025 times 10 to the second. So on these, it depends on where it's coming from. This one's going to be coming from the negative side. So 9.13 times 10 to the negative 3. This one's coming from the negative side. So 4.21 times 10 to the negative 3. This one would be, since the decimal's right here, and it's coming from the positive side, 8.3459 times 10 to the 4th. So you got some problems you need to play with. Some are in scientific notation and they want you to go to standard form, and some in standard want you to go to scientific. Thank you.